do it. All right. So, what is an array? And this is where we're starting, right? It is spelled A-R-R-A-Y. Why are you not typing? A-R-R-A-Y. This is what we're talking about when we're talking about arrays. This is how we spell it. And all it means is it is a list or group of similar type variables. So if I wanted to create a variable of everybody in this room, right, then I would have to make a string variable called student01 and set it equal to Mike. And then I would have a string variable of student02, set it equal to Joshua. And then I would so forth and so on until I had 13 different students, right? Because I'm not counting Caden, I'm not counting Ethan because they're not here, right?
Not here, he's a second-class citizen.
That's right. That's right. So I'd have 13 different variables, right? And then when I needed to interact with those variables, I would have to type student01 or student02, whatever. That's a pain in the butt. What I can do instead is I can make a string variable called students. We'll just set it like this first. So the square brackets designate that it's going to be an array. It's going to be a list of things. You can put a number in here. You can tell it how many you're going to have. So in this case, it's a string of cars and it has 4 cars in it. And you can designate what the cars are. We're not going to worry about that just yet. So I have 13 students, right? That's pretty good. So now, instead of having to say what's student 01, right? When I want to call this variable or assign this variable, set this variable, then I could just do students 0 equals Mike. And students 1 equals Joshua. Whoops. And then students 2 equals Colton. So forth and so on until we got to everybody in the class. Make sense? Yeah. Now, this is just as much work to set up, right, as the other one. But the cool part about this, and I'm just going to go ahead and I'll get one more student in here. Student 3 is going to be Autumn. And we're going to define our students, and we're going to say that there's 4 slots. So you've probably heard at some point that programmers start counting with 0. And it's true. And this is really where that comes into matter. The very first slot is always going to be designated as the 0 slot. The second slot is always going to be designated as the 1 slot. The third is 2. The fourth is 3. So forth and so on. If you have 4 slots, the last slot is 3. If you have 40 slots, what is the last slot? 39. This will come into play at some point, and you will get an error because of it. But when the error shows up, just remember that the number of slots is always 1 more than the address of the last slot. So these numbers are considered your address. You have a 0, a 1, a 2, and a 3. So Mike's address is 0, Joshua's address is 1, Colton's address is 2, and Autumn's address is 3. Cool? Now, we're going to make a second array. We're going to call this grades. And we're going to say that there are 4 slots for grades. I think you can probably see where this is going. Grades 0 is going to be attached to Mike. Grades 1 is going to be attached to Joshua. Grades 2 is going to be attached to Colton. And grades 3 is going to be attached to Autumn. Does that make sense? So I could then come in and say grades 0 equals, what do you want, Mike? 72. Up 6 it is. Grades 1 could be, what do you want, Joshua?
87.
87. Colton, what do you want? 90, barely an A. Autumn, what would you like? 93. Anything to be better than Joshua?
Gotta be another one.
That ball's kind of low.
All right. So this is fine, right? And we can define them this way. But what's really cool about arrays, first off, in this case, we are defining them with numbers we put in. But we could do a for loop. And now I could do grades I. I can set it equal to something, right? It doesn't matter. So let's say grades I is equal to 100 minus I times 7. I think that'll be okay. So now when it goes through the loop, what is grades 0 going to be? We did this math. When I is 0, what is grades 0? 100, because 100 minus 0 times 7 is 100. What is grades I when I is 1? Minus,
I'm sorry.
93. When I is 2, 86. And when I is 3, 79. So we're assigning value to grades through a for loop, which I think is very cool because we can use different ways to create tons of variables. So I know that this is extremely frustrating for someone to do to you, but I'm going to get rid of my students. And I'm going to get rid of my grades. And I'm just going to call this numbers. And I'm going to make 40 of them. So as long as I is less than 40, my numbers I going to be equal to some random value. How do we do random values? Rand percent. Let's just do 100. Well, let's do 40 plus 60. Doesn't matter. So numbers I, there's going to be 40 of them. They're all going to be somewhere between 60 and 100. Does that make sense? In this case, 60 and 99. Are we familiar with what's going on this line right here? So rand percent, right? All this is doing is picking a number between 0 and 39. And then I'm adding 60 to that number. So it's somewhere between 0 and 100. Or, sorry, 60 and 100.
Just get rid of all the grades.
Yeah, I got rid of numbers, got rid of all the grades. Don't have anything else. So now, let's do another, well, let's just do a C out in here. Numbers I. And we'll put an inline. I gotta have a standard inline. So what's gonna happen here?
I can have 40 character list populated with random numbers.
It's gonna make a 40 character list populated with random numbers. Oh, I have an error because I did what? Unexpected qualified oh. Huh. We have to put this in a main function or it doesn't work. What a dumb mistake, Adam. All right. So it gives me a random set of numbers. This is cool, right? We can do a lot with random numbers. We can do a lot with random values. So much data that we get is not random, but it appears random, right? If I took all of your grades and really graded every assignment from 0 to 100 and gave you a score on it based on a rubric, some of you would get 97s, some of you would get 43s, right? There would be a wide distribution of grades and it would appear random if I put it in. So pretending we have random numbers is a good way to start. So these numbers are cool, right? But they're not in order of anything, right? These are just randomly assigned. What we can do with arrays is go through and actually sort these numbers. Some programming languages have a function called sort. We're not going to use that because that's not any fun. But we are going to talk a little bit about different sorting algorithms. I want a video. Do I want this video? 6 minutes long. It's too long. Is it too long? All right, let's do the 6-minute video. Oh, and we have to watch an ad about Wix. There is audio, but the audio is not super exciting. So we're going to watch it. Do you want me to turn the audio on? Maybe I can't turn the audio on. It might not be plugged in. It's not plugged in. The audio sucks anyway. So what's happening here is when you look at it, these are all random values. The bar represents the high value. The almost 0 represents the low value. And there's all different ranked values along the way. Does that make sense? So this is a visual representation of how the sort is working. This is called a selection sort. I'm going to make this a little bit slower so I can talk about it while we go. It's a selection sort. What it does is it looks at each individual value, and you can go through and watch it again. It's comparing the one value to all of the other values, right? You can see at any point it's picking a red value, right? And it's comparing the green value to all of the red values to see if it fits. Selecting one piece and then moving it basically to the front of the line. Does that make sense? So it's looking at all the pieces, it's finding the next piece and moving it to the front of the line. And as it gets farther along, it gets better at that because it's having to make fewer comparisons along the way. But that's the selection sort, which is pretty fast. The selection sort made 7,875 comparisons. That's a lot of comparisons, right? But it can do that quickly because it's a computer. The next sort is an insertion sort, and it works kind of the same way, except it looks at the insertion sort has, let's say it has 5 numbers. It looks and finds the lowest number, right? And then it puts that in the front. And then it looks at the third number and decides, is that number bigger than the lowest number? And if it is, then it compares it to the second number. And if it's bigger than the second number also, then it leaves it where it is. If it's smaller than the second number, then it inserts it between those two. Makes sense? And then it goes to the next one, and it's just moving them around. It's a little bit faster than the selection sort in some cases. Now I think we can speed it up because we understand the concept of what's going on.
So the red is where the actual sort is taking place.
The red is where the sort is taking place. The green is the number that they're moving.
I feel like this is a real good way to get epilepsy.
I hope not. So this is making 15,000 comparisons instead of 7,000, right? There's a lot more numbers in this, but this is called a quick sort. It's doing basically the same thing, just in chunks and faster. The merge sort, you can see what it's doing. It's looking at individual blocks, merging, sorting them, and then merging those two sets of arrays together. It made a lot fewer comparisons. There's a heap sort, which is really fun to watch.
That is
I don't know what this one is. Called a radix sort. That was fast. There's another radix sort. This is a standard sort. This is just how C++ would sort if you told it to sort. Which is very effective, but not very fast. Stable sort. This is cool to watch. Works kind of like that merge sort, I think, but much faster. How much time do we have left? A couple more. We don't need to look at all of them. Bubble sort, this is the one we're going to program because it's the easiest one. It's not the fastest one, but it does what we need it to do. Boom, bubble sort. Let's watch it slower. So the bubble sort, remember the green, there should be a green of where things are going, but I don't see it. Am I colorblind too much to see a green?
See that one.
So selection sort takes the number and puts it on the left side, right? It looks at all the numbers, finds the lowest one, puts it on the left side. Bubble sort, I think you see, is doing it the other way. It's looking through, finding the largest number, putting it on the right side, and then going through, finding the largest number, putting it on the right side, right? It's a little different, but it's really similar. Go, go, go. You have lots of other sorts. So sometimes sorts are better than others at different things. Some sorts are really, really good if all of your numbers are different. Some sorts are better if you have 15,000 inputs, but only 5 possible numbers they could be, right? Some of them are really good if you have 15,000, but all of them are different numbers, and some of them, it just depends on what you want as to what sort you would get. We're not going to worry too much about the theory of sorting and which ones are better and which ones are worse, because we're not going to program them all, right? But it's enough to understand for the purpose of this class that you can use these techniques to sort arrays. And arrays are just lists of numbers. Now, your array could be a string, right? You can't use sorts on strings like that because they're not numbers. But arrays are really cool when you can actually use numbers. So I wanted to talk about the sorting. Now, I told you that you could nest arrays, right? So I could have what's called a 2D array, which would be something like this, 4, 4. Now, a 2D array, remember now, this was what we called the address before, right? So now we have this, which is the address. So every single value, when it's just, well, let me use numbers 4 and then int more numbers 4, 4. So when we're looking at numbers, your address can only be 0, 1, 2, or 3, right? They're the only possible locations that you can have in numbers. But when we look at more numbers, now remember how we nested that for loop and we got 0, 0, 0, 1, 0, 2, 0, 3. We did that last class. This is what we're doing with these arrays. So now you have a 0, 0 address, a 0, 1 address, a 0, 2 address, a 0, 3 address, a 1, 0 address, a 1, 1 address, so forth and so on, a 1, 2 address, a 1, 3 address, and then a 2, 0, so forth and so on, right? So now your address is using both of these numbers to figure out what value you're actually changing. Does that make sense? So we're changing the 0 value here, or the 1 value, or the 2 value, or the 3 value if we have numbers 4. Those are the only 3 values we can change. So we could do numbers 0 equals whatever. We'll say 15. Numbers 1 equals 20. If I could type, this would go better. Numbers 2 equals 25. And numbers 3 equals 30. Or 40, whatever, 30. Right? So this is how we would assign values to these individual variables. If we're working with more numbers, we'd have to say 0, 0 equals 15. Make sense? Then more numbers, 0, 1 equals 20. And you could go through and assign it to now, instead of just having 4 values, you have, what's that, 16 values? 2, 3, 4, 16 values, I think. That's what we end up with.
So each thing in brackets is just replacing your comma.
Yeah. Wait, so this is an address right here, right? This is an address. This is an address. This, right? These are all the types of addresses you would have.
So in another language, you might declare that as more numbers, A, comma, B. Like a
Sure.
grid coordinate.
Yeah. Yes.
Okay.
So these do end up being grid coordinates. This is how we can use it to play tic-tac-toe.
Okay.
Right? But we're not going to do that just yet. We're just looking at, you can have a 2D array. Now, technically, you can have a 3D. God, I am struggling. There. You can have a 3D array, a 4D array, a 5-dimensional array, 6-dimensional, 7, 8, 9. Now, obviously, the math on this gets really crazy, right? You get up to 13 and you're working with the string theory, right? If you don't know what the string theory is, watch The Big Bang Theory and they'll talk about it. Or, I don't know, Neil deGrasse Tyson, maybe. I don't remember the guy's name. There's a physicist that talks about it, but I don't remember his name right now. Anyway, you can have as many dimensions as you want, right? Now, we can visualize 2D and we can visualize 3D. Some people can rationalize 4D, but you can have as many dimensions as you want. You can store as many evaluations as you want. We're not going to try to do it with anything more than 2 because I'm not smart enough. Cool. Very cool. All right. Let's see. What else do we need to know about arrays before we can start doing stuff? So each individual address is its own variable, right? So numbers 0 is its own variable. And when we talk about variables, remember we talk about declaring variables and we talk about setting variables. So when we declare a variable, we have to give it a type and we have to give it a name. When we declare an array, we give it a type, a name, and a length. We want it to know how many items we're going to store inside of this array, right? So it's not like going to the grocery store, you don't know what all you're going to buy, right? So you don't have, but some people have a list and they know exactly what they're going to buy. The array is your list. It tells you exactly how many slots you're going to have. Now you can add and remove slots. We'll deal with that later. But the general idea is you know how many slots you're going to have, and then you use those slots to fill things up and to add value to them. So in this case, we're just going to start with numbers. Let's start with I don't know, 15, 12, 86, and 19. So you can manually set the individual values of the array. In this case, you can manually set because there are 4 slots, you give 4 slots. This slot is your 0 slot because we count from left to right. So numbers 0, if I said C out, numbers 0, what is it going to print to the screen? 15. Numbers 1 is 12. Numbers 2 is 86. Numbers 3 is 19. If I try to print out numbers 4, I'm going to get an error because numbers 4 does not exist. There's nothing there for it to print out. It's going to tell me it's outside of the array or unlisted or outside of the list. Yes.
What if you give it another slot up in there?
So if I said this was 5,
Well, what if you just put in another slot without changing?
oh, then it's going to give me an error because it's going to tell me I'm trying to assign a value to a variable that doesn't exist, right? So just the same as when we're working with variables, if I just here try to say x equals to 15, right? Then it's going to give me an error because I've never declared x. Because I've never declared a 5th slot, it's going to give me an error for that as well.
Now, if you declare more slots than you populate, are the
Zero.
slots you don't, they stop after you populate 0? Okay.
I think so.
Okay.
Alternatively, you can not tell it how many you have. And then however many you populate is how many you have. But that only works in the declaration, right? If you don't tell it how many you have, but you don't give it values here, then it doesn't know how many slots you want, right? So now I'm telling it how many slots I want. I'm going to put a slot number here every time because it just gives you opportunity for failure if you don't. So this is how we, let's make this 75 now that we have 5 of them, right? So this is how we assign, or that's how we declare an array. To set an array, you have to choose the number, the address you want to set. So I could set number 0 to 22, and that replaces this 15 with 22. The same way we set and modify variables, that's all we're doing, right? But numbers 5 is really just creating 5 different variables all at the same time. It's faster, it's easier, and you can do things with these that you can't do with regular variables, right? You can sort them. You can't sort regular variables. That's not true. You can't. It's a pain in the butt. All right. If you wanted to set a different number, you could set numbers 4 equal to, I don't know, 54. So now your array would look, when I printed it out, this would be 22, and this would be 54, right? Because I've changed those values. Easy.
Do all character types have to be the same if you declare like a multi-dimensional array?
Yes. So if you declare numbers 5, 5, right, then you can I don't know how to write that in here, if I'm honest. But you couldn't have integers and floats, right? They all have to be the same type. Does that make sense?
Yeah, see, because I'm thinking like if you want to create a record,
Okay.
like let's say we want to know how many pets each person has in this class.
Yeah, yeah.
You could say like Josh, 3, Mike, 7, but they're 2 different character types.
Right.
Is it? You can't do that with that type of array.
So you would just need two arrays, right?
Okay.
So you would have a string array, however many people you have, we'll say 5. Name it names. Oh, sorry. Names 5. And then you would set that equal to, Josh, Mike, whatever. And then you would have an int pets, right? And it would also be 5. And then you would fill in the number of pets that they have. Now, these would be, you would have to attach these, right? Every time you change this one, you would also have to change this one.
So you just have to be more careful about keeping them paired.
Yeah. There's paired arrays. Yeah.
Okay.
But that's all manual. And in C++, it's manual. In Python, you can have dictionaries, right, that have a name and another value that they always connect together. You might be able to have dictionaries in C++, but I've never used them, so I don't know that for sure. Okay, now what do we want to do with this fun stuff? We're going to draw a grid. So we're going to draw a tic-tac-toe grid. We're not going to do anything with it. We're just going to draw it. Is that okay? So we're going to make a string and call it tic-tac-toe grid. Oh man, that's a really long name. What if we just named it grid? Can we do that? So we're going to make a string grid. How many slots are in a tic-tac-toe grid? 9. So we need 9 slots. I'm going to lowercase grid here. That's pretty good, right? We have 9 slots. Now the slots don't have any values in them, but they are strings, okay? I'm going to set a value on all of them. And my value is going to be space, 5 spaces. 1, 2, 3, 4, 5 spaces. And then a vertical line on both sides. So here I'm making a grid, and I want all of my grids to look exactly like this. Because I want them all to be the same, I don't have to go through and draw them all the same, right? That would be a pain. I don't want them all to be that, so I can just set one, and this should default all of my grids to be exactly that, right? Because I'm only putting one thing in here, it's making them all the same. Does that make sense?
Why the brackets instead of?
Why these?
No, those brackets. Yeah.
That's just how you assign the value, because you can't do this, right? Because that tells it how many you have. This is your address. This is your values. It's just a designation to say this is how we're doing the word assigning values. Yeah, so let me make sure this works, because I could look like an idiot if it doesn't. So we're going to do a cout and grid I. We'll start with that. Let's run it and see what happens. No errors. I got one of those, so it did not apply this to all of my slots. I don't like that. Sometimes C++ is worse. That's okay. 2, 3, 4, 5, 6, 7, 8, 9. Now we'll run it again. Have an error. Expected expression. I hate most everything. Replace my commas with semicolons and pray I'm doing the right thing for the formatting. And I did not do the right thing with the formatting. Forgive me. I'm doing this right. I'm doing this right. String, grid, 9. Open bracket. Close bracket. Oh. Get out of the way. Flip those two on every single one. God, I hate myself. Ding. Forgive me. I think that's 9. Let's find out. What do you want now? Praise. All right. 1, 2, 3, 4, 5, 6, 7, 8. I need one more to make 9. All right. Have a string named grid. It has 9 slots. Each slot is basically just a space that looks like this. When I print it out, I get 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is almost tic-tac-toe, right? Except that they're not stacked like they're supposed to be. So we need a 3 by 3. You could do a 3 by 3 array, right? And that would give us a grid that was 3 by 3, but you can't assign the value to it the same way that I did. This is going to give you a bunch of errors or weird characters. So to assign a 3 by 3 grid, to make it easy, we're going to use a nested for loop. So we're going to start from 0 to 3. We're going to have another for loop starting at 0 and ending at 3. And then inside of this, we're just going to set grid I, j, equal to what I had before, a bar, 5 spaces, and another bar. Now, theoretically, this should draw 9 little grid boxes. Oh, it's not going to draw them. Why would it draw them? I didn't tell it to draw them.
You need that other one.
Which one? This one? I'm defining what the grid is, and then I'm printing it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I want to draw 3 lines across, and then I want to return and draw 3 more grids, and then return and draw 3 more grids. That's what I want to do, right? Because of the fact that I've nested my for loop, I can put a C out here that all it does is end the line. So it makes a return. So it's going to go through this loop and draw 3 lines or 3 grids, and then it's going to return, go back up to here, come down, go through this loop again, draw 3 grids. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 grids that are in the orientation of tic-tac-toe. If you don't like that, then you can have fewer spaces. It looks like that. I'm going through and I'm changing a lot of things as I go, and I apologize for that. I know that's not a fun way to learn because you type it and then you have to erase what you typed, and that's frustrating. So what I'm going to do is I'm going to take a 10-minute break, and I'm going to leave just this here for you all to copy if you want, so that we have a grid that we've drawn that we can do other stuff with. Resume. All right. So what I've done is I've made a counter. The counter is just going to count 1 up to 9 because we have to have a location for people to be able to tell where they are going to put their mark. So with the counter is an integer. In order to get the counter stored in the output for grid ij, which is a string, we had to convert our integer counter to a string. And I forgot how to do this. I had to look it up because I thought it was toString, but I thought it was toString like this, and it's not. Oh, get out of here. It's to_string, and you have to have the std because everything we do with strings right now has to have a std in front of it. So I've made a string that is a bar plus string counter plus this. Now this will allow us to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is just showing everything out. But we only want to show the number if grid ij does not equal an x or an o. Right? Once the player chooses to put an x or an o in there, we don't want it to say 1 anymore, do we? So we're going to have to put an if statement in here. If grid ij does not equal x and does not equal, and grid ij does not equal o, then I'm going to set it to this thing. And probably the way I'm going to designate it, I need it to be like this x and this o. Now, with if statements, a lot of the times when we're evaluating the same value, we like to do what I just tried to do, where it said if grid ij does not equal x and does not equal o, right? Because in my mind, when I'm using English, I would say if this doesn't equal x and it doesn't equal o. My computer can't do that. My computer needs to know exactly what it is that I am comparing to o. So you have to type in the value again because it treats every single comparison as an individual unit, right? It's comparing just these two, and then it's comparing these two. So you have to be very explicit in what you want it to compare. So as long as it doesn't equal an x and it doesn't equal an o, I want to set it equal to my counter, and then I'm going to see out whatever it is. right? In this case, it's going to be the counter. So now I need the user to be able to change grid ij, whether it's 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? Which means we have to have some sort of user reply. We'll do int user reply. I cannot type. And we're going to set that to -1 to begin with. The reason we're going to set it to -1 is because -1 is not an option they're actually going to choose. So there's no chance that we accidentally change a value before the user wants us to. It's generally just a good strategy to make the default value something that could never exist. Now, 0 also could never exist because the numbers are 1 through 9, but the counter does start at 0. It just seems easier to make a -1. That's the same thing. Now, here we are drawing the grid. In every loop, we're going to just draw the grid. But that means that all of this could probably go inside of its own function, right? So we're going to create a function, a void function called draw grid. And all this is going to need is a string grid 3, 3. And then because we've already drawn it all, we can just copy all of this up and paste it in my draw grid.
Can I pull you aside? On the grid ij where you're converting to string,
Yes.
what's happening inside
This,
that the one right below it?
this.
Yeah, with like what are the pluses on either side doing for us?
So you can add strings together, right?
Right.
And the pluses just allows you to do that. So what we're doing is this is the left side, this is the middle, and this is the right side. So my string is, it's basically when it's 1, right? It is drawing 1, right? Because that's what it's doing. It's a bar and a space. So a bar and a space. And then whatever the counter is, in this case 1, and then a space and a bar.
So you've done the, what do you call it, concatenated
Yeah.
strings.
I've just concatenated 3 strings together to get the visual that I want, right? And the visual that I want looks like this.
And the reason you have to convert is because it could show a variable in between.
You cannot assign a string or an integer variable to a string. So I had to convert my counter to a string before I could assign it to the value of a string. There's other ways to do it, but this is the way that I chose to do it. For better or worse. So now I have a draw grid. So in my main, I can draw grid using my grid. When I run it, I get an error because counter doesn't exist. Because we're using counter inside of our nested for loop, we have to declare counter inside of our draw grid function. I have an extra brace, which means down here I'm probably missing a brace. Copy and pasting is bad. All right, so it's doing the same thing. I'm just drawing the grid, but I could draw this grid a whole bunch of times. And every time it runs, it's going to draw the grid again. Now, this is good because my grid is going to change depending on what my user does, right? So we're going to put this in a while loop because we're playing tic-tac-toe. And we don't know if it's going to take 5 turns or 9 turns for the game to be over. It was going to take at least 5. But we're not calculating the win condition. So a while loop's just not going to work because we don't have time to calculate the win condition. So we're just going to pretend it takes 9 times every time. We'll modify this later. But right now, we're going to have, get out of here. What are you doing? There we go. We're going to have a for loop. It's going to run 9 times, which means my user is going to pick where they want to place their mark 9 times. So inside the for loop, we're going to do a C out. This says, where would you like to place your mark? Then we're going to draw the grid. And then we're going to do a C in where we get the user reply. This is going to be a pain in the butt. If user reply equals 1, grid 0, 0 equals this case X. That makes sense? Because they're going to put an X in square 1, which is here. Make sense? But they can have 9 different options. User reply equals 2. We know that 2 is 0, 1. Else, we know that 3 is 0, 2. Let's make sure. I'm going to play it. We're going to get an error because we didn't put a semicolon. Not ideal, but we'll say 3. It puts an X in 3. Say 1. Going to put an X in 1. 2. Going to put an X in 2. Pretty good. It doesn't do anything when we say 4 because we haven't programmed that yet.
Where did you declare user reply up there?
User reply is here. It starts off as -1, and then they assign a value to it. But because we have 9 different options, right? We have to have 9 different else ifs. So 3, 4, 5, 6, 7, 8, 9. Technically, we're going to have 10, but let's just pretend we only need 9 because people don't suck. Which brings me to my next point. Anytime you're programming anything, 3, 4, 5, 6, 7, 8, 9. I have one too many. Anytime you're programming anything, certainly a game, you have to take into account that people suck. In this game, we want them to pick a number between 1 and 9. But a person could come in and place 14 in as their choice. What do we want to happen when they place 14 as their choice?
It says they're stupid.
That's totally reasonable, right? You have to have something that happens.
Try again.
Try again, or you lose your turn. Stupid. Whatever it is. Anyway, so right now it's going to draw an X in every slot, and they get 9 tries, right? So 1, 2, 3, 4, 45, 4, 5, 6, 7, 8, 9. Stupid. All right. That didn't work. Why did that not work? Oh, I know why. Didn't change the grid coordinates. So now we have 0, 2, we have 1, 0. We have 1, 1. We have 1, 2. We have 2, 0. We have 2, 1. And we have 2, 2. Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Game's over. We did play 9 times. We chose 9. We didn't draw that last X as organization, right? But everything else is working. Pretty straightforward. But we don't want to draw an X every time, right? At some point, we need it to draw a 0 or an O. So whose turn is it? So we will make an integer called whose turn. We're going to start it off at 0. Every time the user gives a reply and draws something, we're going to say if whose turn equals 0, then we want whose turn to equal 1. Else, we want whose turn to equal 0. That make sense? You're just flipping it back and forth. Now, we could use a Boolean on this, and we could just say whose turn equals not whose turn every time. So if it's true, then it becomes false. If it's false, it becomes true. I'm not doing that because I don't want to.
Change your declaration.
You would have to change the declaration up top. So in this case, we're using an if statement because I think that it makes it a little bit clearer what's happening. So whose turn equals 0, which means in every single incident where we get to choose something, we have to say if whose turn equals 0, then grid 0, 0 equals X. Else, if whose turn equals 1, grid 0, 0 equals O. Now this is a pain in the butt because now we have to go through and change all of these grids to be this way. Which I will do, but I'm going to pause the recording for that.